Linear programming application problem solving. We're going to use Microsoft Excel to solve this problem. This is from the Russell and Taylor Operation and Supply Chain Management 10th edition book, problem number 51. In this problem, there is an emergency situation and they're going to send the 15 victims to 3 different hospitals based on their conditions. So, for example, the patient number 1 is best treated in hospital C, and then second best option for patient 1 is hospital M, and then third best option is hospital A. So, for example, patient 10, that patient is only treated best in hospital C and M, and the second best option is A, but there is no third option. So it probably has a condition where, so these are the priorities that these different patients have. You can read this problem, and the question it is asking is to find out the send the victims to these 3 hospitals so that they get their priority. They get the service the best, their condition is served the best. At the same time, have 22 or less minutes of transportation or driving from that place. So here's the data I have already copied, and the capacity of the hospital is given. The time it takes from each hospital from this particular disaster place is 10 minutes, 20 minutes, and 35 minutes. And then they have this capacity for hospital C, M, and A, 8, 10, and 7 respectively. So we'll have to set this problem in a way so that we can use this solver function in Excel. We have done this in so many other ones. I'm going to move that to here. Let me make it a little bit smaller so we can read it better. Here we go. So these are the different patients. Maybe you can have that copied too. So right here, so just preparing so that we can use the solver function. Now I'm going to create a column here called send and sum of all of these numbers here. Right now there is nothing. You can type 0, so Excel will start with 0 and then optimizing from there to give us the best option after running those equation behind the scenes. If you don't put anything, it will still work, but 0 kind of makes sense. You start with 0 and then replace with some numbers. And then the total here, we need the sum of patient here. That should be exactly equal to 1, because you can only send 1 patient to 1 hospital like that. And then I'm going to calculate the total miles, just I'll say miles driven or transportation time. I'll say time, transportation time. So I'll use a sum product function. We've been using this for most of these problems. The way we set up, it makes a lot of sense. So this will be multiplied by this. Well, no, I don't really need that. So I'm trying to find out the total time. So that's the time it takes from this disaster place to these hospitals. And then I think I will still need the sum product. So sum product of this time, comma, the number of patients sent to each of these hospital here. So that's the time it takes. And to get the average, we can simply divide by 15 because we have 15 patients total. So that's the average. Now priority score, we can simply do sum product of these numbers, comma, with this priority score. The lower it is, the better. So number 1 hospital for patient 1 is better in this case. So like that. I think we are ready to run the solver function. So we're gonna go to create a copy of this clean data. So in case we mess things up, we can still go back. So go to data, solver, and then we're going to optimize the priority. We'll make it as the minimum as possible. That means the best option. So lower the better here. So going to optimize these numbers and then add constraint. This must be a binary choice. You can't send half patient to a place. So those should be binary number, and then this should be exactly equal to 1. We want to send all patient to this different hospital, and then we cannot send more than the capacity. So this is the hospital capacity. I think we're done, and this should give us a solution. Simplex algorithm. Hit OK. So that's the solution to this problem.